Heard of the Pythagorean Theorem or the Pythagoras Theorem, and today we're just going to do some few examples and I'll make another video showing why this theorem works. So what this says is that a squared plus b squared is equal to c squared. Okay, we know what it says, but what does that actually mean? So assume we have a triangle, right? Let's say we have a right angled triangle, and a right angled triangle means that one of the angles in the triangle is 90 degrees. So in our case, I'm going to make this angle here 90 degrees. No, I'm trying to just make a straight line first. We don't need that. Okay, I'll just try to draw as straight of a line as possible. So let's say we have that, and then we have that. Okay, and let's say that's 90 degrees right there. Okay, so what is A, what is B, what is C? Well, these are just side lengths. Now, how do I know what is A, what is B, and what is C? Now, the important thing is, C is always opposite the right angle. So you see, this is the right angle right here. There are three sides in a triangle, right? And two of the sides will be making the right angle. Whatever side is not making the right angle and that is opposite to it will be the side C. And now A and B, you can make any of these A and B's. You can make this A and this B, or you can make this A and this B. It doesn't really matter. So C is the side opposite the right angle, and C is also called the hypotenuse. And a hypotenuse is the longest side in a triangle. And it makes sense, right? When you're adding two sides up and you're getting the third side. So of course you expect this side to be longer than the other two. Now let's look at some examples on how to work with this. So let's say I gave you the numbers. Now I'm going to give you some numbers. So imagine this is the right angle triangle. And even if it doesn't look like a right angle, as soon as you add this thing right here, that means it's a right angle. So in this case, now we have a right angle triangle. Let's say I gave you the lengths 3 and 4. And I wanted you to find the length C over here, question mark. How would you do it? Well, just use the formula, right? So a squared plus b squared is equal to c squared. So that means 3 squared plus 4 squared is equal to c squared. Okay, what is 3 squared plus 4 squared? This is 9. 3 squared is 9. Plus 4 squared is 4 times 4 is 16. This is equal to c squared. Okay, now we have 9 plus 16, that is 25. The 25 is equal to c squared. Now remember, we need c, we don't need c squared. So the way you get that is to take the square root on both the sides. So then I have the square root of 25 is equal to the square root of c squared. Well, if you take the square root of squaring something, that's just getting rid of everything, right? So you're left with square root of 25 is just 5. So you're left with 5 is equal to, and then these square root and the square cancels out, and you're left with c. So you're left with c is equal to 5. And that means that this length right here is 5. Let's do another example, right? Let's say I give you another right angle triangle. Actually, let's make it look different so then we can recognize what the hypotenuse is. So let's say I gave you the triangle that looked like this. Let's say I give you that triangle, right? And as I tell you this is the right angle right here, that means that this length right here is going to be C automatically, because I'm telling you that's the right angle. So the side opposite the right angle is always the length C, or the hypotenuse. So let's say I gave you the numbers 8 and I gave you 15 and I wanted you to find C. How would you do that? Well, you have 8 squared plus 15 squared is equal to c squared. What's 8 squared? 8 squared is 64 plus 15 squared is 225, and that is equal to c squared. Now what's 225 plus 64? That is 289. So you have 289 is equal to c squared, and you take the square root of that, then you get c is equal to the square root of 289, and you end up getting, one sec, you have 8 squared plus 15 squared, and then you take the square root of that, and you get 17. Oh, so this is actually another perfect number. I was expecting a decimal place, but we ended up getting a square number. So you can see 8, 15, and 17 work. So sometimes you get decimal places. So sometimes if I gave you the numbers, for example, if I gave you the numbers 2 and 3, I gave you 2 and 3, and then I told you to find c over here, you would have 2 squared plus 3 squared is equal to c squared. So you have 4 plus 9, so you have 13 is equal to c squared, and you're left with c is equal to the square root of 13, which is equal to 3.605. So you're left with c is equal to 3.60555, whatever, right? But you can see this is still bigger than any of these two sides, because this side is always going to be the longest side. If you end up getting the hypotenuse as being shorter than the other two sides, then you need to check what you're doing. Maybe you saw the hypotenuse, or maybe you've done the calculation wrong, because this side C must always be the longest side. So in this case we got a decimal place, but in this case 17 and in this case 5, we didn't get a decimal place. So we have something called Pythagorean triples. And you don't have to even know this. This is just like for your information if you want. So this is when like three integers or like numbers without decimal places work in this theorem perfectly. So in this case, 2, 3, and 3.60555 would not be a Pythagorean triple because the 3.60555 is like a decimal place. But when we had 8, 15, and 17, that worked. So you have 8, 15, and 17. This is a Pythagorean triple. When you had 3, 4, 5, that worked because it's a Pythagorean triple. Because these are all proper integers. There's no decimal places. This is just something if you want to know. These are what they're called, Pythagorean triples. Another example would be 6, 8, and 10. You can try it out. This would also work. This is also a Pythagorean triple, and you can see this right here is just 3, 4, 5 multiplied by 2. So 3 times 2 is 6, 4 times 2 is 8, and 5 times 2 is 10. And of course, if you multiply by 2, all you're doing is you're making this side twice as long, this side twice as long, and this side twice as long as well. Now, what if, let's make it interesting. So let's say I gave you the hypotenuse, right? Let's say I gave you, this is the right angle, so this is the hypotenuse. Let's say I gave you the length here is 9. And then I gave you one other length. I gave you, let's say, 3, for example. And I want you to find this length right here. So I'm going to do question mark. How would you do that? Well, you know this squared plus the question mark squared is going to give you 9 squared. So you have 3 squared plus, let's call the question mark an x, okay? Let's just call it x. Plus x squared is going to give you 9 squared. Right? This is just a Pythagorean theorem so far. A squared plus b squared is equal to c squared. So you have 3 squared is 9. Plus, now you don't know what x is, so we just leave it as x squared is equal to, now we know what 9 squared is, right? That's 81. So you have x squared is equal to 81. Now what can we do? If you subtract 9 from both sides, then we're left with x squared is equal to 81 minus 9, which is 72. And now we can find the square root of 72 to give you x. So the square root of 72 is equal to 8.485. Equal to 8.485. And that's the value of x. And you can see, this is still less than 9, which is the longest side. So you can always check that if it's not the hypotenuse, it will always be shorter than the hypotenuse, because the hypotenuse is the longest side of the triangle. And you can try if this works, right? So that means that 3 squared plus 8.485 squared should give you 9 squared. So let's see. So 3 squared is 9, and then 8.485 squared is 71.99999. So I have 71.995 is equal to 81. Let's check if this is correct. I'm going to do a question mark. And then with 71.995 plus 9 is 80.995. And of course, since we rounded the numbers, since this is not actually equal to 8.485, there's like more decimal places, then of course you won't get exactly the right number, but you can see we came very, very close to it. We're just 0.005 off. So if you have the hypotenuse given to you and you want to find the other side, you can just rearrange the formula by subtracting one side and then take the square root and you'll find the shorter side. So I hope that made sense. In another video, I'm going to do a proof of this theorem and see where it comes from and why it works. So I hope you enjoyed. If you did, like, share, comment, subscribe, and let me know what else you want to see in future videos.